You know, sometimes the universe hides its most dramatic stories in the most unassuming places. Take Messier 71. It's tucked away about 13,000 light years from us in the constellation Sagitta, and for the longest time, it just looked like any other star cluster. But it was hiding a secret, a really violent past that turned it into a master of cosmic disguise. So today, we're going to open up the cold case file on this deceptive cluster and figure out its true identity.
And this was the central mystery, the question that really stumped astronomers for years. What exactly is M71? Is it a young, kind of loosely packed open cluster? Or is it one of those ancient, super dense globular clusters? I mean, its appearance was so misleading that nobody could agree.
And right there, that's the heart of the problem. When you look at M71, it just seems sparse. It's all spread out. It's missing that classic, tight, spherical shape that just screams globular cluster. It just didn't fit the profile at all.
Okay, so to really get what's at stake here, you have to know the two main suspects. First, you've got open clusters. Think of them as the cosmic youngsters, right? They're maybe 100 million years old, loosely bound, and they hang out in the busy, flat disk of our galaxy. Then you have the globular clusters. These are the ancient ones. We're talking 10 to 12 billion years old. And they're these incredibly dense balls of stars orbiting way out in the quiet suburbs of the galactic halo. They are totally different kinds of star families. And this quote just nails the whole debate perfectly. M71 didn't fit the mold. It had the age of a globular cluster, but it had the looks of an open cluster. It was this huge cosmic contradiction that just had to be solved.
All right, so let's get into the investigation. The first big break in the case came when astronomers decided to look past its appearance and started analyzing the stars themselves. And what they found was that M71, well, it wasn't one big happy family. Turns out, the stars had these distinct chemical fingerprints. It's kind of like finding two different strands of stellar DNA. And what that meant was there were two separate populations of stars living together in the same cluster, born at different times and from slightly different stuff. So here are the two families. You've got the first generation, which formed from the original pristine gas cloud, and then a second generation formed later from gas that was, let's say, polluted with heavier elements that were cooked up inside those first stars. Now, here's the kicker. Only massive, dense globular clusters are big enough to hang on to that polluted gas and form new stars. Finding two generations is their hallmark. This was a huge, blinking neon sign pointing away from M71 being a simple open cluster.
Now check this out, because you're literally looking at the evidence right here. This chart, it's called a color magnitude diagram, is how astronomers can actually see these two families. I know, it might just look like a bunch of dots, but to an astronomer, this is a family portrait, and it clearly shows two distinct groups of stars living side by side. But you guessed it, here's where the plot thickens. In almost every other globular cluster, that second generation of polluted stars vastly outnumbers the first. But in M71, it's the total opposite. The first generation is the dominant one. This was completely backwards. So the evidence was saying, yes, it's a globular cluster, but a really, really weird one. The mystery just got a whole lot deeper.
So that led to the next big question. What in the universe could make a globular cluster look so sparse? And why were its two populations so perfectly mixed together? That's something you only see in clusters that are dynamically old, meaning they've really been through a lot. Well, the answer wasn't a what, it turns out. It was a where. You see, the motive for M71's strange appearance wasn't something that happened inside of it. It was something that happened to it. It was all about its orbit. Unlike most globulars that get to travel safely through the empty galactic halo, M71's path is a dangerous one. It forces it to plunge right through the heart of the galaxy, over and over again. I mean, just think about this. It's like building a sandcastle right where the tide comes in. Every single pass M71 makes through the dense, chaotic plane of the Milky Way is like a giant wave crashing over it, just stripping away its stars for billions and billions of years. And the price of that brutal journey? A whopping 90%. That's right. The cluster we see today is just a ghost of its former self. It's a stripped-down survivor that was probably once up to 10 times more massive. So its sparse appearance, that's not how it was born. It's a scar from its violent life. And hey, this also explains why its two stellar populations are so well mixed. All that constant gravitational churning just stirred them together perfectly.
But this story has one last absolutely incredible twist. The very same violence that tore M71 apart also somehow created an unexpected safe haven for some of the rarest stars in the cosmos. And this was the smoking gun that confirmed its entire history. So when astronomers pointed an X-ray telescope at M71, this quiet, sparse cluster suddenly just lit up. It was teeming with these incredibly energetic, high-energy binary star systems. This was a complete shock for a cluster that seems so calm and, frankly, a little bit boring. And this was a huge paradox, right? These exotic X-ray binaries, they're usually formed when stars collide in the super-dense cores of massive clusters. So how on earth could a lightweight, sparse cluster like M71 have so many of them? It just didn't make any sense. Well, the answer is that these particular binaries weren't formed by collisions at all. They're what we call primordial active binaries, basically systems of two stars that were born together as partners. And the thing you need to know about them is that they're incredibly fragile. And here it is, the final, most beautiful piece of the puzzle. The very process that stripped away 90% of M71 stars also made it way less dense. Now, in a denser cluster, these fragile primordial binaries would have been ripped apart by other stars ages ago. But in the sparse, stripped-down M71, they were safe. They were preserved. The violence that nearly killed the cluster is what actually saved its rarest inhabitants. How cool is that?
So, the case is closed. M71 is no longer some obscure anomaly. It's a crucial piece of evidence. It's become this perfect cosmic laboratory for studying the dramatic lives and deaths of star clusters.
So let's just quickly recap the case file on M71. We now know it is a true globular cluster, but one that has lived a very hard life. Its dangerous orbit through the galaxy cost it most of its mass, and that explains both its sparse appearance and its perfectly mixed populations. And then, in this amazing twist of fate, that very same mass loss protected a rare zoo of primordial binary stars, giving us this incredible window into the universe's past.
The story of M71 really proves that some of the universe's most amazing histories belong to the objects you'd least expect. It really makes you wonder, doesn't it? What other cosmic secrets are out there, hiding in plain sight, just waiting for us to crack the case?